Hello, welcome to the chapter Is Matter Around Us Pure? Part 3. In last video, I told you about solutions, their concentration, their dilution, saturated solution, etc. In this video, I am going to discuss with you different types of solutions based on their size of the solute particles. So, you know what is a solute particle, which is taken in lesser amount in a solution, is the solute. And based on the size of the solute particles, solution is divided mainly into three types. They are true solution, suspension and colloid. So, solution is divided into two. They are true solution, suspension and colloid. We can discuss the physical properties or the properties of this true solution, suspension and colloid. So first one is true solution. What do you mean by that? An example for true solution is salt water. Vellam, salt will dissolve in the salt solution is an example for a true solution. So what about the size of the particles? Is it visible to us with our naked eye? For example, here I am having salt dissolved in water. This is salt dissolved in water. Can you see any salt particles here? No. That means the solute size is too small. We cannot see it with our naked eye. So, the salt particles are too small that we cannot see it with our naked eye. And the size of this particle is less than 1 nanometer. 1 nanometer means it is equal to 10 raised to minus 9 meter. അത്രയ്ക്ക് ചെറുതാണ്. അത്രയ്ക്ക് അതായത് 0.0090 കഴിഞ്ഞിട്ട് 1. അത്രയ്ക്ക് ചെറുതാണ് size of this solute particles in a true solution. So we are going to discuss some of the properties of true solution first. So first example for this true solution is salt water. Then we are going to discuss some of its properties of true solution. First property is I told you, the size is less than, size of the solute particle is less than 1 nanometer. That is first property. Size is less than 1 nanometer. Second property is it homogeneous or heterogeneous? In the last video class, I told you about homogeneous and heterogeneous mixture. If they are having same composition throughout, they are called homogeneous mixture. We know that when salt is dissolved in water, the salt molecules will mix thoroughly in the water molecules so that they are having the uniform composition throughout. So, this is a homogeneous solution, or we can say true solutions are homogeneous. Second property is they are homogeneous. Then the next property is, the third property is the particle size is too small. So they don't have the power to scatter the light falling on it. See, for example, if light falls on it, the solute particles are too small. Its size is less than 1 nanometer. So they are not able to scatter the light. ഇപ്പോൾ തന്നെ ഒരു തടിച്ചൊരു കുട്ടി ദേഹത്ത് നമ്മൾ ഓടിപ്പോയി ഇടിക്കുകയാണെങ്കിൽ ഇത് സംഭവിക്കുന്നത് നമ്മൾ തെറിച്ച് വീഴും. കാരണം എന്താ, സൈസ് ഭയങ്കര കൂടുതലാണ്. അതേസമയം ഈ വാട്ടറിൻ്റെ പാർട്ടിക്കിൾസ് അതിനകത്ത് ഇപ്പം ഈ സോൾട്ട് പാർട്ടിക്കിൾസ് ദേ ആർ ടു സ്മോൾ. സോ വെൻ ലൈറ്റ് ഫോൾസ് ഓൺ ഇറ്റ്, the light is not able to get scattered by these solute particles, or scattering of light is not possible by the solute particles because its size is too small. So the next property is that they cannot scatter the light because the size of solute particle is too small. Then the fourth property is they are highly stable. What do you mean by stable? See, when I am keeping this salt solution for hours or for days, they will never settle down. The salt will never settle down at the bottom. The salt particles are very small. They get dissolved in water. They never settles down. That is another property of the true solution. They are highly stable. The particles will never settle down. So they are highly stable. The particles will never settle down. Then the third property, the fifth property is that since the size of the solute particle is too small, they cannot be separated by the process of filtration. Filtration പോലുള്ള ചെറിയ പ്രോസസ് ഒന്നുകൊണ്ട് നമുക്ക് അല്ലെങ്കിൽ സിമ്പിൾ ആയിട്ടുള്ള ഫിസിക്കൽ മെത്തേഡുകൾ കൊണ്ട് you will not be able to separate the solute and water or the solute and the solvent. So they cannot be separated by the process of, or they cannot be filtered. Or when we are taking a filter paper and we are passing this salt solution through it, means no residue is obtained. That means the solute particles are too small, they will pass through this filter paper. So these are all some of the properties of true solution. So the example for the true solution is salt water. Another example is sugar water or sugar solution. These are all some of the examples of copper sulfate dissolved in water. All these are true solution. So what are the properties of true solution? First thing is the size is too small, less than 1 nanometer. The second thing is since the size is too small, they are homogeneous mixture. Since the size is too small, they cannot scatter the light. Since the size is too small, they cannot settle down, or they will not be able to settle down at the bottom of the vessel or the container in which we are taking it. And the last property is since the size is too small, they cannot be separated by the process of filtration. They need some other methods. For example, to separate salt and water, we need the process of evaporation. All those techniques you will be studying in the later classes. So these are all some of the properties of true solution. And the last one is its example: salt solution, sugar solution, copper sulfate in water. All these are examples of true solutions. Coming to the next one, other part. Opposite that is suspension. So I am going to discuss with you next the properties of suspension. So the size of the particle, first one, the size of the particle is greater than 1000 nanometer. That means the size is too high. We can see it with our naked eye. I will give one example. This is example for a suspension, that is the soil dissolved in water or sand dissolved in water is an example. Sand dissolved in water, chalk powder in water, all these are examples of suspension. Can you see the solute particles? Here the solute particle is the sand particle. We can see it with our naked eye. Its size is greater than 1000 nanometer. So first thing is its size is greater than 1000 nanometer. Is it homogeneous or heterogeneous? The water particle is seen in one layer and the soil is seen on the other layer. That means it is not having a uniform composition throughout, or it is heterogeneous. Then will they be able to scatter the light? Size of the particle is too high that they can scatter the light. But remember one thing, they are not suspending here. They are settling at the bottom, no? So when the light is passing through the water, means they will not be able to scatter the light. Why? Because the heavier solute particles are seen at the bottom of the vessel. So when the light is passing through the water, means they cannot scatter the light. When the light is passed through this heavier particles or soil particles, they can scatter the light. Then the next thing is they cannot be filtered in the case of true solution. What about here? They can be filtered through the filter paper. When we are pouring this soil or solution or this mixture, means what will happen? The size of the soil particle is too high that they will remain there on the top of the filter paper. Only the water will go through the pores of the filter paper and the sand will remain there. So they can be separated by the process of filtration. The next thing is example. Example I told you, soil in water or sand in water is an example for a suspension. So I can say once again, what is suspension? Is it stable? No, it's not stable. It is highly unstable. It will settle at the bottom of the vessel. Then the solvent will be seen on one layer and the soil will be seen on the other layer. That means they are highly unstable. They will not remain as a solution. They will settle down because of its large size. So I will say once again the properties of suspension. First property is suspension. The size of the particle is greater than 1000 nanometer. The size is too high. We can see it with our naked eye. Here the solute is the sand I am taking. The second thing is they form two different layers. They are not uniformly distributed, so they are heterogeneous mixture. The third thing is, since their size is too high, they can scatter the beam of light falling through it. But majority of them will be settling down at the bottom. They are highly unstable solution. And the last one is they can be separated by the process of filtration, because the size of the solute particle is too high. They cannot pass through the pores of the filter paper. So that is about suspension. Example is soil in water, chalk powder in water. Chalk powder will not dissolve in water. They form two different layers, so they are heterogeneous. So all these are examples of suspension. നമുക്ക് എഴുതാം, ജസ്റ്റ് ഒന്ന് എഴുതാം എന്തൊക്കെയാണ്. സൈസ് ഗ്രേറ്റർ ദാൻ first one, suspension size greater than 10 nanometer, sorry 1000 nanometer, size greater than 1000 nanometer, heterogeneous, can scatter the light, fourth one, they are highly unstable, and the fifth one is they can be filtered. Example is chalk in water or soil in water, soil water mixture or salt water, sorry chalk water mixture. They are all examples of suspension. Then the last one is colloid. The third one is colloid. Colloid means their particle size is in between that of the true solution and suspension. It is not too small as true solution and it is not too big as suspension. In between this. So the size of the colloidal particle will range from 1 to 1000 nanometer. 1000 nanometer മേളിലാണെങ്കിൽ സസ്പെൻഷൻ ആയിരുന്നു, 1 നാനോമീറ്ററിൽ താഴെയാണെങ്കിൽ ട്രൂ സൊല്യൂഷൻ ആയിരുന്നു. അപ്പം 1 to 1000 നാനോമീറ്ററിന് ഇടയിൽ നിൽക്കുന്നതാണ് colloids. So colloids are having the size ranging from 1 to 1000 nanometer. So we can write the colloids. I will give an example for colloid. See this one here. This is an example for a colloid. What is this? Milk in water. Milk in water. See, listen here. Its size. Can you see it with our naked eye? Its size is in between 1 to 1000 nanometer. Then the size is in between that of the true solution and suspension. Then is it a homogeneous or a heterogeneous mixture? It appears to be homogeneous. നമുക്ക് കാണുമ്പോൾ തോന്നും it is homogeneous. Actually it is oil, fat, etc. dissolved in water. Can never be homogeneous. It is actually heterogeneous. It appears to be homogeneous, but actually it is a heterogeneous solution. Fatum, oilum, lipids ഒക്കെ കൊണ്ടുണ്ടാക്കിയതാണ് വാട്ടറിൽ മിക്സ് ചെയ്തിട്ടുള്ള ഈ മിൽക്ക്. They can never be homogeneous. They appear to be homogeneous, but they are actually heterogeneous. So the size is in between 1 to 1000 nanometer. They are heterogeneous in nature. The third property is scattering the light, isn't it? They are very good in scattering the light. The property of colloid to scatter the light is called the Tyndall effect. About this you will be studying in detail. Tyndall in your 11th standard class. Tyndall effect. The tendency of colloidal particles to scatter the light is called Tyndall effect. They are able to scatter the light. Are they stable or unstable? Will they settle down at the bottom of when we keep it for some time? No. Milk is not so. They are quite stable. They are quite stable. That is another property, and can be separated by the process of filtration? No. See, a special technique called centrifugation is required for its separation. What is centrifugation? You know what is centrifugation? See, we are taking this solution and we are rotating it very fastly. So what will happen now? The denser particles will be moving in one position and the lighter particles of this solution will be moving in another particle. Churning, നമ്മൾ പാല് അല്ലെങ്കിൽ വെണ്ണ എടുക്കുന്നത്, നെയ്യ് എടുക്കുന്നത് പാലിൽ നിന്ന് അല്ലെങ്കിൽ കേടിൽ നിന്ന്, ഇതെല്ലാം this process is because of centrifugation. So milk is a colloidal solution and it can be separated. It cannot be separated by filtration. Size അത്രയ്ക്ക് വലുതല്ല, അതുകൊണ്ട് filtration method വരില്ല. We require the process of centrifugation. Centrifugation means turning the solution in very rapid speed so that denser particles will be moving in one point and the water particles or the lighter particles will be moving at that point. That is the principle behind centrifugation. Above this also you will be studying in your the later portion. Separation of the mixture. There you will be studying about centrifugation, evaporation, etc. So I will say about the colloid solution once again. The properties. First property is, example for the colloid is milk in water. First property is they appears to be homogeneous but they are heterogeneous. Their size is in between 1 to 1000 nanometer. Then they are quite stable. They are able to scatter the light and this property is called Tyndall effect. Then they can be separated by the process of centrifugation. So that is about the properties of colloids. I will write it. By this we can finish the class. So centrifugation and the Tyndall effect we will be studying later in this chapter. So first one is properties of colloid. First property is they appears to be homogeneous but they are actually heterogeneous solution. Second property is they can be the size is in between 1 to 1000 nanometer. The third property is that they are quite stable. Then the fourth property is that they possess or they show Tyndall effect. What is Tyndall effect? The ability of the colloidal particles to scatter the light is called Tyndall effect. And the fifth property is that they can be separated only by the process of centrifugation. What is centrifugation? It means turning the solution rapidly so that the denser particles will be depositing in one area and the lighter particles deposit. Turning of milk, separating the ghee from milk, separating the butter from milk, all these are process of centrifugation. And the example is milk in water or milk plus water. So based on the size of the solute particles, we are dividing the solution into three. They are true solution, suspension and colloid. You should have to study it by comparing the properties of the three types of solution. I think the video is useful for you. Thank you.